Hello there, and welcome to the Drift to the Stars. I'm so glad you found your way here tonight. Wherever you are right now, tucked into bed, stretched across a sofa, lying quietly in the dark, you made it here. That's enough. You don't need to do anything else tonight. There's nowhere to be, nothing to solve, no version of yourself you need to perform. This is simply a place to rest and to drift and to let the world grow gently large around you while your body grows gently heavy. And just before we begin, if these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, if you're ready, let's begin. There is a sound the earth makes that no human ear has ever heard. Not because it is too loud, not because it is hidden, but because it is too slow, too deep, too constant, like trying to hear the color of a room you've lived in all your life. It moves through everything, through the oceans, through the bedrock, through the floor beneath you right now. Scientists call it the Earth's hum, a continuous, low vibration that rises from the planet's own interior, its own movement, its own living weight. Even in the most soundproofed room ever built, this hum is present. Even in the quietest valleys, on the quietest nights, it is there. It does not announce itself. It simply continues, the way a river continues whether or not you are watching it. Think of it as a song with no beginning and no planned ending. A note held for 4.5 billion years. You have been inside this song for every moment of your life without knowing it. And there is something quietly comforting in that. The earth has been making this sound since long before there were ears to miss it, and it is making it still, right now, as you settle into stillness. You are not in silence. You are in the oldest music there is. Now hold that feeling of vast, slow sound, and then consider something much smaller. Consider a single thunderstorm, the kind you might watch from a window flicker of light, a low roll of sound, rain moving across a field in grey curtains. From where you sit, it seems enormous. The sky itself seems to be rearranging. But from space, from a satellite watching in infrared, a thunderstorm is a small and temporary brightness, a smear of light on a blue-grey surface. And here is what gently undoes expectation. Even a great earthquake, the kind that reshapes coastlines, the geologists name and remember, releases less total energy than that single thunderstorm, viewed from that same distance. It is not that earthquakes are small, it is that weather is enormous, and we forget. The atmosphere above you is constantly churning, releasing energy in quantities that dwarf the grinding of continents. The sky is wilder than the stone. A magnitude 8 earthquake releases roughly the energy equivalent of about 6 million tons of TNT. A large thunderstorm system can release several times that, over its lifetime, in heat, wind, and electrical discharge. The ground beneath you is patient. The sky above you is the restless one. And right now, both are holding you, from below and above, like a hand cupped around something small and warm and worth keeping. Somewhere inside you, there is stone. Not metaphorically, not as poetry. Literally, the calcium in every bone you have ever grown, the magnesium that moves through your blood, the silicate traces in your hair and skin, these are minerals. The same category of matter that makes up the tectonic plates sliding beneath every continent on Earth right now. You are, in a measurable chemical sense, made of the same stuff as fault lines. Imagine the bones of your hand, the fine architecture of them, the way they hinge, the way they hold. Now imagine those same minerals under different conditions, compressed by unimaginable weight, heated by the interior of a planet, folded over millions of years into ranges of stone. That is what the Earth did with the same atoms. And then, somehow, across an incomprehensible chain of events. Some of those atoms found their way into you, into the quiet machinery of your living body. The pressure that builds along a fault line and the pressure that built your skeleton are not the same, but they rhyme. The earth made both from the materials it had. It did not distinguish. It shaped rock, and it shaped you with the same patient chemistry. You are not a visitor to a geological world. You are a geological event, a temporary, breathing, wandering arrangement of the very same matter. Right now, as you read this or as this voice reaches you in the dark, the ground is moving somewhere on Earth. Not in a way anyone will feel, not in a way that will make the news, or rattle a window, or wake a dog. Somewhere, a small seam in the rock gives way. Somewhere, a fault that has been holding steady for years releases a fraction of its tension. The movement is tinier than a grain of rice shifted across a table. But it is real, it is measurable, and no creature in the world notices. Seismologists estimate that the Earth experiences roughly 500,000 detectable earthquakes every year. That is nearly 1,400 per day, nearly one per minute somewhere on the planet. Most of them happen beneath ocean floors. Most of them register so low on the scale that the most sensitive instruments can only barely catch them. They are like the smallest exhales of a sleeping person, real breaths, just quiet ones. And somehow, knowing that is not alarming. It is settling. The Earth is always releasing, always adjusting, always making these tiny, unheard corrections. It has been doing this for billions of years, and the mountains are still here. The oceans are still in their places. You are still here. All that adjusting and still, this much stability. The planet is not fragile. It is alive. The deepest earthquakes on Earth happen in a place no human instrument has ever physically visited, and no human being will ever go. Nearly 700 kilometers below the surface, far deeper than any drill has ever reached. Far deeper than the deepest mine. Far deeper than the deepest ocean trench there is, a region where the rock is no longer rock in the way we usually mean it. The pressure is so severe that minerals transform into new forms, denser and stranger, that do not exist at the surface. The temperature is hot enough to melt most things, but the pressure keeps the rock from melting entirely. It flows, instead, slowly, like something between a solid and a dream. And through this zone, earthquakes still happen. A stress still builds. A release still occurs. A seismic wave still rises upward through 700 kilometers of layered earth, and eventually, almost gently, reaches the surface as a barely measurable whisper. It is extraordinary that we detect them at all. That a movement in a world utterly invisible to us under all the cities, under all the oceans, under all the history, can still reach up and announce itself, still make itself known. There is something quietly wonderful in that. Depth does not mean silence. Even what is most hidden still sends something upward. Even what is most remote still arrives, eventually, at the surface where you rest. A seismic wave, the energy released by an earthquake, travels through the earth at several kilometers per second, through dense rock, through liquid iron, through the strange interior regions of the planet. It moves and curves and reflects until it has visited the entire sphere. And here is where scale does something gentle to the mind. Light, traveling from the surface of the sun to the surface of the earth, takes about 8 minutes. A seismic wave, traveling through the entire planet, not across it, but through it, pole to pole, takes roughly 20 minutes. Light and earthquakes. One crosses 150 million kilometers of empty space. The other crosses 12,700 kilometers of dense, layered rock, and they arrive at their destinations within minutes of each other. It is not a competition. It is a proportion, a way of holding two enormous things beside each other until the mind stops trying to measure and simply rests in the comparison. The planet is not small. The speed of light is not modest. And somehow, they rhyme. When sunlight is falling on your window, soft morning light, or the last orange of an afternoon, a seismic wave somewhere is moving through rock at a pace that is, in its own way, just as astonishing. Both are traveling. Both are real. Both pass through and around and over the place where you quietly exist. Long before seismometers, long before anyone understood fault lines or tectonic plates, ancient people built sacred structures on living ground, and they did not always know why. Temples in Greece, sanctuaries along the Anatolian coast, certain cathedrals in Italy, oracle sites, healing centers. Many of these, when mapped by modern geologists, sit directly on or very near to active fault lines. The connection is not coincidence, researchers believe, but an ancient, unnamed sensitivity. The ground near a fault often produces strange phenomena, faint smells of rising gases, occasional ground-level sounds too low to identify, the faintest vibration underfoot on certain days. People felt something. They could not name it. They built temples. Whether the experience was sacred or geological or both, in some way we have lost the language, for there is something tender in that history. Humanity has always been drawn to the places where the earth is most alive, even without instruments, even without understanding. Something in the body recognized the living quality of the ground. You don't need to be near a fault line tonight to feel that recognition. You are resting on a planet that is breathing beneath you, and some part of you very quietly already knows. The ocean floor is the most active surface on Earth, and also the most quiet. More than 70% of all volcanic activity on the planet happens beneath the ocean, along the mid-ocean ridges, where tectonic plates are slowly pulling apart. New seafloor is being created right now, in the dark, miles below the surface, in water so cold and pressurized that the magma cools almost instantly into strange, rounded shapes called pillow basalts. And as this happens, tiny tremors ripple outward, micro-earthquakes so small they are measured in fractions of a degree. The ocean absorbs these entirely. No wave reaches shore. No instrument on shore detects anything. The movement happens in total, absolute silence, muffled by miles of cold water and the weight of the world above it. Imagine moving so gently, so far beneath attention, that even the restless ocean doesn't transmit your presence. That is the daily reality of the seafloor. It changes constantly, in the dark, under immense pressure, in cold and silence, without any witness. And yet it is real. And yet it matters enormously, shaping the ocean basins, regulating chemistry, building the foundation of every coast you have ever seen. Work does not require an audience. Quiet change is still change. The world is made, in large part, by things no one has ever seen. Here is something that reorders the world a little. Modern seismometers, the instruments that detect earthquakes, are sensitive enough to detect a sparrow landing on a branch nearby. Not metaphorically, not approximately. A small bird, alighting on a wooden branch 50 meters from a buried seismometer, produces a vibration in the ground that the instrument can detect and record. The footsteps of a single person walking across grass can be measured at a distance of 10 meters. The passage of a car on a nearby road appears as a clear, identifiable pattern on a seismograph. A thunderclap, a wave breaking on a distant shore, a large crowd beginning to applaud. The ground carries everything. It does not filter for importance. It does not decide which vibrations deserve recording. It simply transmits faithfully, without judgment. Every pressure, every weight, every movement placed upon it. And your body, right now, is part of that record. Your heartbeat creates a tiny mechanical wave in your chest that travels into the surface beneath you. If you are lying down, the ground beneath you is, in the most literal physical sense, registering that you are here, that you are alive, that your heart is beating. The earth knows you are resting on it, not in a poetic sense, in a physical one. You have always been felt. The mantle, the vast layer of rock between the earth's crust and its core moves. Not quickly, not in any way you could watch, but it moves. The rock there, under enormous heat and pressure, behaves over millions of years like an extraordinarily viscous fluid. It convects hot material rising, cooler material sinking, in vast, slow loops that carry continents on their backs. The speed of this movement is roughly the same as the speed at which your fingernails grow, 1 to 2 centimeters per year, a few millimeters per month, less than a hair's width per day. And yet it has moved India across the Tethys Ocean and into Asia, raising the Himalayas in the process. It has opened the Atlantic. It has carried Australia northward from Antarctica, all of it at the speed of a growing fingernail, without hurry, without urgency, over timescales that make human history feel like a single breath. There is such peace in that pace. Nothing about the Earth's interior is rushed. It does not try to go faster. It moves at exactly the rate that its nature allows, and in doing so, it remakes the surface of the entire planet. You don't have to be fast to matter. You don't have to be sudden to be powerful. The slowest forces on Earth are the ones that make the mountains. Right now, somewhere between 50 and 100 separate earthquakes are happening simultaneously across the surface of this planet. Not one after another, all at once. A quiet chorus of releases spread across the ocean floors, tucked beneath mountain ranges, humming through the deep rock of ancient continental shields. None of them fierce enough to wake anyone, none of them large enough to move a glass of water on a table, but all of them real, all of them measurable, all of them part of the same continuous breathing that the planet has been doing since its crust first hardened from cooling magma. Scientists monitoring global seismic networks watch this happen every hour of every day. The screens show it clearly. Dozens of small events, blinking into existence and fading, scattered across the map like fireflies in a dark field. 50 earthquakes at once, and the world feels perfectly still. There is something deeply reassuring in that proportion. All that movement, all that release, all that adjustment, happening simultaneously beneath oceans and ice sheets and sleeping cities, and the surface holds. The birds stay on their branches. The rivers keep their courses. You remain exactly where you are, undisturbed, held steady by a crust that knows, after billions of years of practice, how to carry everything placed upon it without letting any of it feel the effort. Somewhere in a university laboratory, or a geophysics research station, or a quiet basement lined with recording equipment, someone has slowed down the sound of an earthquake, not amplified it, slowed it, stretched the frequency of the seismic wave until it falls within the range of human hearing, and what comes out, when you listen, is something that does not sound like destruction, or chaos, or any of the things the word earthquake might suggest. It sounds like a cello, a low, resonant, slightly mournful note, held and then fading, sometimes with overtones, sometimes with what sounds almost like vibrato. The specific character changes with the depth of the quake, the type of rock it passed through, the distance it traveled, but the quality is consistent, warm, low, sustained. The Earth, when translated into human hearing, sounds like an instrument being played by someone who is not in a hurry. Seismologists have actually used this technique to study earthquakes. Converting seismic waves to audio helps them identify patterns that visual graphs don't always reveal clearly. The ground beneath you has a voice. It is too low for you to hear without translation, but if you could hear it tonight, it would not alarm you. It would sound, more than anything else, like music played quietly in another room, present, unhurried, and somehow familiar, as though you had heard it before in a dream you can no longer quite place. Before the first fish left the ocean, before the first insect spread its wings, before any living thing had learned to walk on land, the continents were already moving. The tectonic plates have been in motion for somewhere between 3 and 4 billion years. Life on land, by comparison, has existed for perhaps 400 million. That means the plates were drifting, colliding, separating, and reshaping this planet for more than 2 billion years before any creature existed that could stand on them and feel curious about what was happening. The Himalayas did not wait for someone to admire them before they rose. The Atlantic Ocean did not need an audience before it opened. The ancient supercontinent of Pangaea assembled itself and broke apart in a world that had not yet invented the eye. All of that movement, all of that vast reshaping of the surface of the earth, happened in a kind of solitude that is difficult to imagine. Not loneliness exactly, more like the quiet work of something that does not require witness to be real. And now you are here, aware of it, able to look back across billions of years of movement and understand, at least in outline, what happened. The Earth moved for billions of years without anyone knowing, and then, eventually, it made something that could know. That is, you, resting here tonight, thinking slowly about deep time. There is a place in Antarctica called the South Pole of Inaccessibility, and another in the middle of the Pacific Ocean, and a third in the Sahara, where the wind rarely blows and the nearest human being might be hundreds of kilometers away. These are among the quietest places on Earth. And yet, in all of them, the ground vibrates, not from anything nearby, from the ocean, from waves breaking on coastlines thousands of kilometers distant. The energy of those waves, pressing rhythmically on the seafloor, generates a continuous microseismic hum that travels through the crust of the entire planet. Every coastline on Earth, every moment that waves are breaking, is sending a faint vibration outward through the rock. Seismologists call this the secondary microseismic peak. It is one of the most consistent signals on the planet, present in every seismographic record ever made, on every continent, in every season. The ocean's rhythm is inside the land. Even in the driest desert, even beneath the deepest ice, the sea's breathing can be felt. You are near the ocean tonight, or you are far from it. It does not matter. The ocean is already there, in the ground beneath you, arriving as it always does, patient and continuous, the way the ocean has always been, finding its way into everything, even the stillness of stone. Some earthquakes last for what feels, on a human scale, like no time at all, a fraction of a second, the duration of a blink, less time than it takes to register that something happened. The rupture propagates along a tiny section of fault, releases its small parcel of energy, and is finished before the signal has even reached the nearest seismometer. A single heartbeat, by comparison, lasts about 0.8 seconds. Many micro-earthquakes are over in a third of that. They begin and end within the space between one pulse and the next. And they are still real earthquakes, still classified, still recorded, still part of the planet's ongoing seismic story. The Earth does not require drama to qualify as alive. Some of its movements are gentler than a thought, briefer than a breath, and still entirely genuine. There is something restful in that. The idea that consequence does not require duration, that a thing can be real and complete and meaningful and still take almost no time at all. A moment of release, quiet as a sigh, and then the rock settles back, and the record continues, and no one felt anything, and the world is unchanged, and also, just slightly, different. Even as you rest right now, your body is doing this too. Small releases, small adjustments, tensions you did not know you were holding, easing away between one breath and the next, briefer than a blink, still real. Beneath every city on Earth, the ground is layered, not randomly, in sequence. Like the rings of an ancient tree, each layer of sediment or rock below a city is a record of what that place once was. Riverbeds, lake floors, coastal dunes, volcanic ash, glacial deposits, marine limestone full of the compressed remains of creatures that lived before the city, before the country, before the language spoken there existed. Geologists read these layers the way a careful reader reads a letter written by someone they never met. The meaning is all there. It simply requires patience and the right kind of attention. Beneath London, there is a layer of river gravel left by the Thames when it ran much further south in a different climate during a warmer interglacial period. Beneath Chicago, glacial sediment from ice sheets that covered the region just 12,000 years ago. Beneath Mexico City, the silts of an ancient lake, Lake Texcoco, which the Aztecs built on, which the Spanish drained, which the city has been slowly sinking into ever since. Every place has this depth. Every place carries its whole history beneath it, quietly, invisibly, with no announcement. The ground you are on tonight has a story stretching back further than any written record. You are resting on compressed time, on layers of everything this place has ever been. Here is a fact that gently reorganizes the sense of danger. A magnitude 2 earthquake, which happens hundreds of times every day around the world, releases roughly the energy of a small firework, a single firecracker, not the grand finale. One small pop. The scale used to measure earthquakes, the moment magnitude scale, is logarithmic. Each full step upward represents roughly 32 times more energy released than the step before, which means the distance between a magnitude 2 and a magnitude 8 is not 6 steps. It is more like 1,000,000 times the energy. The scale compresses enormous differences into small numbers, which makes the small numbers seem closer to the large ones than they are. Most earthquakes that happen today, across the planet, fall well below a magnitude 3. They are, energetically speaking, comparable to things that happen unremarkably in daily life. A car backfiring, a heavy door closing in a large building, a small wave breaking on a rocky shore. The Earth is constantly releasing energy in amounts no larger than a door closing somewhere down the hall, constantly settling, constantly adjusting. And the sound of that settling, if you could hear it, would be entirely ordinary, almost domestic, almost like the sounds a house makes at night when the temperature drops and the wood contracts and the world becomes, again, a little quieter. In basements and converted warehouses and quiet university buildings around the world, seismologists have discovered something unexpected in their data. When stadiums fill and crowds begin to move in synchrony, when tens of thousands of people jump together or sway together or pound their feet on metal bleachers, the ground records it from kilometers away. A concert, a football match, a public celebration. The rhythm of human bodies moving together creates a seismic signature, as clear and recognizable as any tremor. Scientists have used this to study crowd dynamics and to verify attendance at large events. And sometimes, simply because it is there in the data, this clear, rhythmic, unmistakable record of people being together and moving and feeling something at the same time. The Earth records us. Not only our buildings, not only our machines, but our joy. The specific frequency of a stadium singing in unison. The particular rhythm of people dancing in a square at midnight in a warm city. All of it written into the ground, briefly, then fading. Your body is doing something right now that the ground can feel. Your breathing, your heartbeat, the small shifts of weight as you settle more deeply into wherever you are resting. The Earth has been keeping this record since long before you were born. It is still keeping it tonight. Mountains are not sudden things. They are earthquakes, measured in millions of years instead of seconds. The same force, the same compression of one plate against another, the same build-up and release of stress, simply running at a pace so slow that no individual moment of movement seems significant. And yet, over time, through countless small releases, the rock folds upward, the surface rises. What was once a seafloor becomes a peak with snow on it. The Himalayas are still rising, even now, a few millimeters per year, lifted by the ongoing collision between the Indian and Eurasian plates. Every year, quietly, the highest mountains on Earth become a little higher, and they are also being worn away at roughly the same rate by wind and ice and water, so the net change is small. But both processes are real, and both are ongoing, and the mountain is, at every moment, the temporary result of two enormous forces working against each other, neither winning, neither stopping. You are looking at stillness when you look at a mountain, but you are actually watching a very slow argument between the interior of the Earth and the sky. Neither is wrong, neither is finished. The mountain is simply what it looks like when two vast, patient forces meet and hold each other. For now, in balance. The Pacific Plate, one of the largest tectonic plates on Earth, is moving. Right now. Not in geological time, not in metaphor, but literally, physically, at this moment, while you read or listen or drift. It is moving beneath the Pacific Ocean at a rate of somewhere between 6 and 8 centimeters per year, carrying the sea floor and everything on it slowly northwestward. That rate is close to the rate at which human hair grows. Not identical, but close enough to use as a human-scale translation. Your hair, if you left it entirely alone for 1 year, would grow approximately as far as the Pacific Plate moves in that same year. And the Pacific Plate is enormous. If you could lay it flat and visible, it would cover an area larger than the entire land surface of Earth. This vast mass of oceanic crust, moving at hair-growing speed, without pausing, without resting, carrying seamounts and trenches and the floor of the largest ocean on the planet, and it has been doing this, at roughly this rate, for tens of millions of years. It does not accelerate, it does not tire, it simply continues, at exactly the pace that the forces acting on it allow, patient in a way that nothing living can quite be, patient in the way that only the very old and the very large and the very indifferent to hurry can manage. There is something worth resting into, in that pace, something that makes urgency feel, just for a moment, like a misunderstanding. The moon shakes. Not often, not dramatically, but the moon, which most of us think of as the most still and silent thing in the night sky, experiences its own quiet trembling. Moonquakes, as scientists call them, were discovered during the Apollo missions, when astronauts left seismometers on the lunar surface, and those instruments kept sending data back to Earth for years afterward. There are several kinds. Some are caused by the gravitational pull of the Earth, stretching the Moon very slightly as it orbits. Some come from the slow thermal expansion of the surface as sunlight returns after 2 weeks of darkness. Some come from deep within the Moon's interior, from regions that are still not fully understood, for reasons that scientists are still working to explain. The Moon is still settling, still adjusting to the way it formed billions of years ago. In the aftermath of a collision so large, it reshaped both the early Earth and whatever struck it. That settling has been going on ever since. And on quiet nights, in the most literal physical sense, the Moon shivers. Something about that is deeply companionable. The Moon that has watched over every sleeping creature that ever lived. Every tide, every midnight, is itself not entirely still. It is doing what everything does, given enough time and attention. It is slowly, gently, finding its way toward rest. Beneath the oceans, the Earth's crust is surprisingly thin. If the planet were the size of an apple, the oceanic crust would be thinner than the apple's skin. Beneath the continents, where we live and build and rest, the crust averages something like the thickness of a thumbnail on that same apple. Beneath the oceans, it is thinner still, in places just a few kilometers deep before the mantle begins. This thinness is not a weakness. It is simply a different kind of structure. The oceanic crust is younger, denser, constantly being created at mid-ocean ridges and destroyed at subduction zones, cycling through a process of birth and return that the continental crust does not experience in the same way. The ground beneath your feet right now, if you are on a continent, is ancient in a way that oceanic crust rarely gets to be. Some continental rocks are nearly 4 billion years old. The oceanic crust, by contrast, is almost nowhere older than 200 million years. It gets recycled before it can accumulate that kind of age. You are standing on the old part, the part that has been here long enough to remember things the ocean floor has forgotten. The ground beneath a continent is, in geological terms, something close to an elder, patient and deep and carrying a history that the restless young ocean floor has long since returned to the interior. In 1960, an earthquake struck the coast of Chile. It was the largest earthquake ever recorded by modern instruments, and what followed in the days afterward was something seismologists had theorized but never fully observed. The earth itself began to ring, not audibly, not in any way a person in Santiago or Tokyo or London could hear, but measurable, real, the entire planet vibrating at its own natural frequencies, the way a bell vibrates after it has been struck. These vibrations, called free oscillations, continued for days, the planet oscillating at frequencies so low that a single cycle took anywhere from several minutes to nearly an hour, the Earth breathing in and out at the pace of a very deep, very slow meditation. Seismometers around the world picked it up simultaneously. Every station, on every continent, registered the same gentle, planetary pulse. The whole Earth, moving together, like something that had been reminded it was round. Scientists learned an enormous amount about the interior of the planet from studying those oscillations. The way the frequencies behaved told them things about density and composition at depths no instrument could reach. One earthquake, and the planet offered up its secrets in the form of a song, not a violent announcement, a slow, low, honest vibration, circling the globe for days, saying, "Here is what I am made of. Here is my shape. Here is what is inside me, if you are patient enough to listen." Your skeleton and the Earth's crust share a chemistry that is not accidental. Both are rich in silicate minerals. Both contain calcium, in the Earth's case, as calcium carbonate in limestone, and chalk, in your case, as calcium phosphate in bone. Both are built from elements forged in the cores of stars that existed before our solar system. Both use the same basic atomic building blocks, arranged differently by different pressures and temperatures and timescales, into structures that hold things up. Limestone, which underlies vast regions of the Earth's surface, is made largely from the compressed remains of marine organisms, their shells and skeletons accumulated over millions of years on ancient seafloors. In a sense, the Earth's crust in those regions is itself a kind of bone, a collective skeleton, made from countless small lives, pressed into stone, and your bones, when this life is finished with them, will return, slowly, through processes that take time measured in centuries rather than millennia for the softer materials, longer for the minerals themselves. They will rejoin the ground. They will become, eventually, part of the layered record beneath some future place. The Earth is not separate from the living things that rest on it. It is partly made of them. Every reef, every chalk cliff, every limestone cave is, in the most literal sense, the remains of something that once breathed and moved and was alive. You are surrounded, always, by the transformed remains of life, and you are temporary, living material that will one day become part of the same record. There is a category of earthquake so small, it has its own name, and it sits at the very bottom of the scale. Magnitude -3, below 0 on the moment magnitude scale. This range captures events so tiny that they measure the movement of individual sections of rock a few meters across, shifting by fractions of a millimeter. The energy involved is comparable to a single footstep on soft ground, a book falling from a low shelf, a child jumping once on a wooden floor. These events happen constantly, everywhere, in the rock beneath cities, beneath forests, beneath the ocean floor. They are the background noise of a living crust, the smallest possible expression of the same force that, at the other end of the scale, reshapes continents. The scale is the same, the force is the same, only the magnitude differs, and the magnitude ranges so far in both directions that the smallest and the largest share almost nothing except their category. You exist somewhere in the middle of an enormous range of scales, as you always have, larger than a quartz crystal, smaller than a continent, generating vibrations measurable by sensitive instruments, briefly, warmly, unmistakably present in a universe that contains both the imperceptible and the immeasurable, and holds them all within the same quiet set of rules. There are trees growing along fault lines that spiral. Not every tree, not even most, but in certain places where the ground has been slowly, continuously creeping along a fault, not in sudden jolts, but in the patient, gradual movement called aseismic creep. Trees rooted in the soil above the fault sometimes grow with a gentle twist to their trunks. The roots on one side of the fault move at a slightly different rate than the roots on the other. The tree accommodates. It does not break. It simply grows in the direction that allows it to keep growing. This has been observed along portions of the Calaveras Fault in California, where the creep is measurable and consistent. Orchards planted across the fault line show it clearly. The trunks curve. The rows of trees drift slightly out of alignment over decades. The trees do not know about plate tectonics. They do not resist or comply consciously. They simply respond, as living things do, to the conditions they find themselves in, and find a way to keep reaching upward regardless. There is something in that image worth keeping tonight. The slow twist of a trunk above a moving fault. The way growth accommodates what it cannot change. The way something rooted and patient and alive can cross the boundary between two moving things and simply continue, reaching toward light, spiral, and whole. The Earth does not only absorb heat from within, it breathes it outward, along the same rifts and fault systems that generate small tremors. Heat from the planet's interior moves upward toward the surface. This geothermal heat is not distributed evenly. In some places, Iceland for example, it arrives close enough to the surface to heat homes and generate electricity, and fill outdoor pools with warm water in the middle of winter. But everywhere, even where you cannot feel it, the heat is moving upward. The ground beneath you, right now, is warmer at 1 meter depth than at the surface, warmer at 10 meters than at 1. The temperature increases steadily as you descend, following a gradient that continues all the way to the core, where the heat is comparable to the surface of the Sunday. This warmth is ancient. Some of it is heat left over from the planet's formation, from the violent collisions that built this world out of debris more than 4 billion years ago. Some of it is generated continuously by the slow decay of radioactive elements deep in the rock, elements that have been releasing their energy grain by grain since before the Earth had an ocean. The ground beneath you is gently, quietly warm, has been warm, continuously, for longer than life has existed, will remain warm, long after everything currently living has transformed into something else. A steady, deep warmth, rising slowly toward the surface where you rest. Every so often, before a distant earthquake, birds change their behavior. They go quiet, or they leave a tree all at once, in a sudden rustling departure that seems unmotivated, or they land and then immediately lift off again, restless in a way that observers sometimes notice and remember afterward. The reason, researchers believe, is infrasound. The very lowest frequencies of sound, below the range of human hearing, can be generated by the movement of rock along a fault before the actual rupture occurs. These frequencies travel through both the ground and the lower atmosphere. Some birds, particularly pigeons, are sensitive to infrasound. They may perceive something in the air or in the vibration of their perch that registers as a reason to move. They do not know what they are feeling. They respond to it anyway. The body, theirs and yours, is often ahead of the mind in noticing what the world is doing. Even as you rest right now, your nervous system is doing this, registering pressures and temperatures and sounds below the threshold of conscious attention, processing the room, the air, the surface you are lying on, and finding it safe enough to let the muscles loosen, safe enough to let the eyes stay closed. Your body is a sensing instrument of considerable sophistication, and tonight it is telling you, in its own quiet language, that you can rest. The word seismograph comes from two Greek words. One means to shake, the other means to write. A writing of shaking, a record of trembling. The name itself carries the idea that the Earth's movements are a form of language, something that can be set down, preserved, read later by someone who was not present when it happened. Early seismographs were elegant mechanical devices, a heavy mass, suspended so that it would remain relatively still when the ground moved around it, connected by a lever to a pen resting on a slowly rotating drum of paper. When the ground moved, the pen traced the movement. The Earth wrote its own record, with the instrument only providing the medium. Modern seismographs are electronic, far more sensitive, capable of detecting movements smaller than the width of an atom. But the principle is the same. The Earth moves. The instrument records. The record can be read. There is something quietly profound about that image. The Earth writing its own history, continuously, in every seismograph station, on every continent, in every research vessel floating over ocean trenches, in every borehole and mine shaft where instruments have been carefully placed to listen. A vast, ongoing autobiography, written in the language of motion, by a planet that has never stopped moving and has been writing this way since long before there was anyone to read it. Tonight, you are part of what the ground is writing. Your presence, your weight, your warmth, your breathing body resting on its surface. All of it, in the most literal physical sense, part of the record. The Earth is always giving something back. Along the same fault systems that release small tremors, heat and gas move upward through fractures in the rock, rising toward the surface in a slow, constant exchange between the interior and the air above. Carbon dioxide, water vapor, trace amounts of helium, which is so light it eventually escapes into space entirely, lost from the planet forever, replaced only by the slow decay of radioactive elements deep in the rock below. This exchange is not dramatic. It happens in quiet places, along volcanic margins, in the floors of rift valleys, through the fractured rock beneath hot springs, steam rising from a crack in a hillside, a faint warmth detectable in the soil above a geothermal zone, bubbles rising through the water of a mountain lake fed by a deep spring. The Earth exhales, not metaphorically, but in a genuine, measurable, chemical sense. It releases what has built up inside it, the way any living system must, through the same openings that allow small tremors to pass, the same weaknesses in the crust that mark the boundaries between one piece of the surface and another. These openings are not failures in the rock. They are where the interior and the exterior communicate, where the deep and the surface maintain their long relationship, where the planet, if you were inclined to use the word, breathes. You are breathing too, right now, without thinking about it, in and out, releasing what has built up, exchanging what the body needs with what surrounds it. The rhythm of that is older than you are, older than your species. As old, in its basic form, as the first exchange between the interior of this planet and the atmosphere it slowly, over billions of years, exhaled into existence. Somewhere on Earth, at this precise moment, the ground beneath a sleeping person is rising and falling, not from an earthquake, from a distant one, a seismic wave generated perhaps thousands of kilometers away, too small to wake anyone, too gentle to register in the body's own sensing, but real enough to move the surface by a millimeter or less, a slow rise and fall, like the surface of water after a boat has passed. The person sleeping there will never know. The movement is entirely outside the range of human perception, but it is happening. The ground they are resting on is not perfectly still. It is participating, quietly, in the aftermath of something that happened far away, in a different country, in a different ocean, in a different time zone. We are connected, through the rock, to everything that happens on the surface of this planet, not symbolically, through actual physical transmission. A tremor in Japan reaches California as a measurable, if tiny, movement of the ground. A rupture beneath the Indian Ocean sends waves of energy through the crust that arrive in Norway minutes later. The ground is a medium. Like air carries sound, rock carries these signals, in all directions, always, without preference for which signals to pass and which to stop. Everything travels. Everything arrives somewhere. The Earth does not keep anything entirely to itself. Before an earthquake sometimes, the ground exhales something invisible. Radon, a naturally occurring radioactive gas, forms deep in the Earth through the decay of uranium and radium in rock. Under normal conditions, it seeps upward slowly, through tiny pores and fractures, emerging at the surface, in trace amounts that vary by region and geology. But when stress builds along a fault, When the rock is being compressed or stretched in the slow accumulation that precedes a rupture, the fractures change. New micro-cracks open, old pathways widen slightly, and radon, following the path of least resistance upward, can rise in greater quantities, detectable by instruments placed in the soil or in groundwater near active faults. Scientists have been studying this for decades, hoping it might become a reliable warning signal. The results are promising but not yet consistent enough to predict earthquakes with confidence. The Earth offers hints. It does not always offer certainty. What is certain is that the ground is always in quiet conversation with what lies above it. It sends up gases and heat and vibration. It receives the weight of water and ice and stone and the soft pressure of everything living upon it. This exchange never stops. The boundary between the ground and the air above it is not a wall, but a conversation, continuous and ancient, conducted in languages too slow and too low for most of us to notice. There is a category of earthquake that takes a month to finish. Scientists call them slow slip events, or sometimes silent earthquakes. They involve the same basic mechanism as a regular earthquake. Two sections of crust moving relative to each other along a fault, but instead of releasing their accumulated stress in seconds, they release it over days, or weeks, or in some cases months. The movement is so gradual that no seismic wave of consequence is generated. No shaking, no sound, nothing any person would feel. The only way to detect them is through GPS instruments, measuring the position of the ground so precisely that movements of a few millimeters over several weeks can be identified as a coherent pattern of slip. The instruments show the ground moving, slowly, continuously, then stopping. The fault has adjusted, the stress has been partially released, and no one felt anything at all. These events happen regularly in places like New Zealand, Japan, and the Pacific Northwest of North America. They are not rare. They are simply invisible to every sense a human body has. The Earth resolves its tensions without drama when it can. Given enough time, given the right conditions, even the largest accumulations of stress can be released so gradually that the surface above remains undisturbed. Patience, in geology as in so much else, changes everything about how a force expresses itself. When a seismic wave moves through the Earth, it carries information, not intentionally, not in the way a message is encoded and sent, but the wave's behavior changes depending on what it passes through. It slows in some materials and speeds in others. It bends at boundaries between different kinds of rock. It reflects off the inner surfaces of the planet. And when it arrives at a seismograph on the far side of the world, the record it leaves carries, embedded in its shape and timing, a description of everything it traveled through. This is how we know the Earth has layers. This is how we know the outer core is liquid and the inner core is solid. This is how we know the approximate thickness of the mantle and the depth at which certain minerals change their crystal structure under pressure. None of this has ever been directly observed. All of it has been inferred, carefully and painstakingly, from the behavior of seismic waves making their way through the planet. The waves do not know they are carrying this information. They are simply energy, moving through a medium, following the rules that govern how waves behave. And yet they tell us, if we are patient and skilled enough to listen, the shape of things that no eye has ever seen and no hand has ever touched. There is a kind of knowledge in the world that arrives only through indirection, through what something does rather than what it is, through how it bends, how it slows, how it changes in the presence of what surrounds it. The Earth has been read this way, carefully and with great patience, by people who understood that not every truth presents itself directly. Your heartbeat creates a vibration in the ground. Not a large one, not one that would appear on any standard seismograph record, buried as it would be in the background noise of traffic and wind and the 1,000 other signals the ground carries at any moment. But it is there, in the physics, in the way a beating heart creates mechanical waves in the chest that travel outward through the ribs and the flesh and the surface you are resting on. Seismologists studying very sensitive instruments in very quiet locations have detected the heartbeats of nearby animals, and in some cases, of people sitting motionless close to a buried sensor. The signal is faint. It requires extraordinary stillness in the environment to isolate, but it exists. Your body is a source of seismic energy, small, rhythmic, continuous, a pulse that the ground, if it could pay attention in that way, would recognize as a living thing at rest, something warm and regular and alive, pressing its weight and its rhythm gently into the surface of the planet. You have always been felt, in this sense, by the earth beneath you. Every heartbeat since the one that started this particular life has sent a small mechanical wave outward into the ground. The earth has been keeping that record, faint and buried in noise, since the first moment you existed. You have been announcing yourself, quietly, all along. The fault lines of California are moving, not in the catastrophic sense that fills disaster films, but in the same patient, continuous way that all active faults move. Parts of the San Andreas fault system creep steadily, millimeter by millimeter, without locking, without accumulating the kind of stress that leads to large earthquakes. In the town of Hollister, the creep is slow enough and steady enough that it has bent curbs, offset roads, and gradually split buildings that were constructed directly above the fault. Over millions of years, this movement is carrying the western edge of California northward, relative to the rest of North America. Los Angeles is moving towards San Francisco at roughly the pace hair grows, and in approximately 15 million years, if the movement continues, the two cities will be neighbors. This is not an emergency. It is geology doing what geology does, at the pace geology does it, on a time scale that makes the entire span of human civilization look like an afternoon nap. There is a particular kind of peace available in deep time, the perspective that comes from holding a very long view, in which the anxieties of any given moment become very small against the backdrop of continental drift and deep ocean formation and the slow, patient rearrangement of everything. The world is changing. It has always been changing, and the pace of that change is, in most cases, gentle enough that everything living on the surface has time to simply continue being alive. The sun has earthquakes. The surface of the sun, which is not solid but a roiling layer of plasma, is subject to waves and oscillations that seismologists have adapted their methods to study. The field is called helioseismology, and it has revealed things about the interior of the sun that could not be known any other way. Just as seismic waves traveling through the earth carry information about what they passed through, acoustic waves traveling through the sun's interior and reflecting off its surface carry information about the layers below, the temperature gradients, the rotation rate at different depths, the presence of convection zones and the boundary between them. The sun is ringing constantly, in thousands of overlapping modes of oscillation, each one a slightly different frequency, each one shaped by the interior it passes through. The combined effect, translated into sound and dramatically slowed, resembles something between a drum beat and the resonance of a very large room. We are orbiting a star that hums, that rings, that carries within its light and its gravity and its constant solar wind some faint acoustic echo of its own interior. Every ray of sunlight that has ever fallen on your face came from something that was, in its own way, quietly vibrating. The warmth was never entirely still. It arrived from a source that has always been in motion, always been singing, in frequencies too vast and too remote for any ear to catch. In the deep valleys and old mines where the most sensitive seismometers are installed, the instruments are sometimes placed inside cavities carved from solid rock. The rock itself acts as a dampener, absorbing the surface noise that would otherwise overwhelm the delicate signal. Traffic, wind, the movement of people, rainfall on the surface above, all of it is muffled by the intervening stone, until what remains is the deep, quiet signal of the Earth's own movement, separated from everything human and incidental. These are, in a real sense, listening rooms, spaces designed entirely around the act of paying attention to something very faint and very important. The walls are the listener, the instrument is the ear, and what is being heard, patiently, continuously, is the planet itself. There is something worth imagining in that. A carved room deep in old rock where instruments wait, in the dark, for the earth to say something. Not demanding, not impatient, simply present, and ready to receive whatever arrives. You might be doing something similar right now, quieting the surface noise, letting the louder signals of the day fall away, waiting, without quite knowing what for, in a stillness that is not empty, but full of things arriving too quietly to name. The body knows how to do this. It has always known. It learned from a planet that has been listening to itself, in the dark, for a very long time. The first seismograph was built in China in the year 132 AD by a mathematician and astronomer named Zhang Heng. It was a bronze vessel, roughly the size of a large urn, decorated with 8 dragons facing outward in 8 directions, each dragon holding a bronze ball in its mouth. Below each dragon sat a bronze toad, mouth open, waiting. Inside the vessel, a pendulum was suspended, sensitive to the ground's movement. When a tremor arrived from a particular direction, the pendulum swung, a mechanism released, and one dragon dropped its ball into the waiting toad's mouth below. With a clear, ringing sound, the instrument detected an earthquake approximately 500 kilometers away, in a region where no one at the imperial court had felt anything. Days later, a messenger arrived confirming that the earthquake had indeed occurred, in exactly the direction the dragon had indicated. 5 centuries before Europe had anything comparable, a bronze dragon dropping a ball into a bronze toad in the silence of a palace courtyard, announcing something that had happened far away, in a place no one in that courtyard could see or feel. The impulse to listen for what the earth is doing is not modern. It is ancient and persistent and cross-cultural. Humanity has always wanted to know what the ground is saying, has always been drawn to the question of what moves beneath us, has always, in one form or another, built the instruments and the patience required to listen. Somewhere beneath you, stress is accumulating in rock, not alarmingly, not in a way that has any bearing on tonight, or this week, or likely this decade, but somewhere in the geology below wherever you are resting. 2 sections of crust are pressed against each other, held by friction, accumulating the slow debt of movement that the forces acting on them are continuously demanding they make. This accumulation can take centuries. Certain faults in the Pacific Northwest of North America have been building stress for 300 years, since the last great rupture along the Cascadia subduction zone. The rock remembers, in the sense that the stress is physically present, encoded in the deformation of the crust itself, waiting for the conditions that will allow it to release. Geologists can read this weighting in the landscape. Uplifted coastlines, tilted lake sediments, the subtle warping of the ground surface detectable only by precise GPS measurements over many years. The Earth keeps its own account. It does not forget what it is owed, and it repays, eventually, always, on a schedule entirely its own. There is something clarifying in that kind of patience. The rock does not rush the release. It does not manufacture urgency. It simply holds what it holds, continues to accumulate what arrives, and waits for the moment when conditions allow the balance to shift. The waiting is not passive. It is a form of readiness, which is different and quieter, and in its own way, more powerful. Water can trigger earthquakes. Not ocean water pressing on the seafloor, though that plays a role too, but fresh water. The filling of a large reservoir behind a dam adds an enormous, concentrated weight to the crust in a specific location, and that weight can increase the pressure in the rock below, lubricating faults that might otherwise have remained locked for decades longer than they do. This was observed at the Hoover Dam, and at the Kariba Dam in Africa, and at the Zipingpu Dam in China. In each case, seismic activity in the region increased following the filling of the reservoir. The earthquakes were generally small. The connection to the reservoir was, in most cases, carefully established through the study of timing and location. Water, the gentlest and most yielding of substances, pressing downward with enough accumulated weight to change the behavior of faults. The softest thing influencing the hardest. This is not a warning. It is a reminder of how connected everything is. The hydrological cycle and the tectonic cycle and the erosional cycle are not separate systems running in parallel. They are one system, continuously interacting, each part affecting every other in ways that took centuries of careful observation to begin to understand. When it rains on a mountain, the mountain feels it, not immediately, not dramatically, but eventually. There are places on Earth where the ground is still moving upward, and the reason is ice that melted 10,000 years ago. During the last great glaciation, ice sheets, kilometers thick, covered much of northern Europe and North America. The weight of that ice was so immense that it pressed the crust downward, compressing the mantle rock beneath, pushing it slowly aside. When the ice melted, relatively quickly in geological terms, the weight was removed, and the crust, relieved of its burden, began to rise. It is still rising. In parts of Scandinavia and Canada, the ground is lifting at rates of a centimeter or more per year. Harbors that were once at sea level are now several meters above it. Ancient shorelines that were once beaches are now inland meadows. The mantle beneath flows so slowly that it is still catching up to a change that happened 10,000 years ago. The crust is still remembering the ice, still returning to the shape it held before the weight arrived. Even as you rest right now, parts of the Earth are slowly rising in response to something that ended before any civilization now living had begun. The planet's memory is long, and its recovery is patient, and it does not hurry, even when the cause of the change is long gone. The body of the Earth, like all bodies, takes its own time to find its way back to where it wants to rest. You have never been completely still, not once, not for a single moment of your entire life. The Earth rotates at roughly 1,600 kilometers per hour at the equator, carrying you with it as it turns. It orbits the Sun, moving through space at roughly 30 kilometers per second. The Sun itself orbits the center of the Milky Way, carrying the entire solar system at a speed that dwarfs both of those. The Milky Way moves through its local group of galaxies. The local group moves through the larger universe. All of this, always, beneath whatever sense of stillness you have ever felt. And then beneath your body, the crust itself is drifting on the mantle. The mantle is convecting. The core is rotating, possibly at a slightly different rate than the surface above it. Every layer of this planet is in motion relative to every other layer, all the time, without pause. Your feeling of stillness right now is not an absence of motion. It is a relationship between motions. You and the surface beneath you, and the planet, and the solar system, and the galaxy are all moving together in directions and at speeds that cancel each other out from your perspective, creating the sensation of rest. You are not still, you are carried. There is a difference, and it matters, and it is one of the gentler truths the universe has to offer. You have never had to hold yourself in place. Something has always been carrying you. The oldest rocks on Earth are over 4 billion years old. They were found in northern Canada, in a region called the Acasta Gneiss, and they formed when the Earth was so young that its surface was still being shaped by the final heavy bombardment of asteroids that characterized the early solar system. There was no oxygen in the atmosphere. There was no life, as far as we know, anywhere. The moon was closer and larger in the sky, and the days were shorter because the Earth rotated faster then, before the moon's gravity gradually slowed it. These rocks have been through everything, every ice age, every mass extinction, every rearrangement of the continents, every change in the atmosphere and the ocean chemistry. They were old before the first fish existed. They were ancient before the first flower opened. They predate, by billions of years, every living thing currently on this planet, including every tree and every ocean creature and every sleeping person. And they are still here, patient and dark and dense and unremarkable to look at, sitting in museum collections and field exposures in remote subarctic wilderness, simply continuing to exist in the way that very old things sometimes do, without effort and without announcement. There is something steadying about the existence of very old things. The world contains things that have lasted through everything, that have been present through every catastrophe and every flowering and every extinction and every beginning. The oldest rocks have seen it all, and they are still here, and they are not alarmed. Every mountain range on Earth was once something else. The Himalayas were once the floor of an ancient ocean called the Tethys Sea. Marine fossils, the remains of creatures that lived in warm tropical water, have been found at elevations above 8,000 meters in the Himalayas. They were lifted there, slowly, over tens of millions of years, as the Indian plate pressed northward into the Eurasian plate, and the seafloor crumpled upward into peaks. The Appalachians, one of the oldest mountain ranges in North America, were once as high as the Himalayas are today. They have been worn down over hundreds of millions of years by erosion into the gentle, rounded, ancient ridges they are now. They are old mountains, tired mountains, in the most affectionate sense. The Alps were once a seabed. The Andes are still rising, still being built by the ongoing subduction of the Nazca Plate beneath South America. Every range has its origin story, and every origin story involves something becoming something entirely different, over time, through force and patience, and the continuous action of processes that do not stop. Nothing stays what it is. The seafloor becomes a mountain. The mountain becomes a plain. The plain becomes a seabed. The same atoms, the same minerals, passing through form after form, never created and never destroyed, simply rearranged by the same forces that have been rearranging everything since the beginning. Whatever you are right now is not the only thing you have been, or will be. A seismic wave, generated by an earthquake on the other side of the world, takes approximately 20 minutes to travel through the entire planet and emerge on the far side. In those 20 minutes, The wave passes through the crust, through the upper mantle, through the transition zone where minerals change their crystal structure under pressure, through the lower mantle, through the boundary between the solid rock of the mantle and the liquid iron of the outer core, through the outer core itself, through the boundary between the liquid outer core and the solid inner core, through the inner core, and then back out the other side in reverse order, 20 minutes, through every layer of a planet, through materials that exist nowhere on the surface and that no human instrument has ever physically entered. And the wave arrives, changed by what it passed through, carrying the fingerprints of every boundary it crossed, a message from the interior, delivered in the form of a tiny, measurable movement of the ground at a seismograph station on the other side of the world. 20 minutes to cross a planet. In that same 20 minutes, you might brew a cup of tea, walk around a neighborhood block, lie in the dark and let your thoughts slow from their daytime pace to something gentler. The wave does not rest. It simply travels through the whole earth and arrives and is received, and the record is kept. And somewhere, someone is reading what it said. Every grain of sand on every beach was once part of something larger, a cliff, a mountain, a boulder tumbled by a glacier, a reef of ancient coral. Over time, through the action of water and ice and wind and the slow grinding of stone against stone, these larger things were reduced, fragment by fragment, to the size of a sand grain, to the size of something you can hold between two fingers and barely feel. This reduction took time measured in thousands to millions of years, depending on the material. It involved the same forces that create fault lines and drive tectonic plates, the same heat and pressure that generate small earthquakes in the deep rock also drives the weathering and erosion that produces, eventually, the sand on every shore. Sand is the end product of a very long process of becoming smaller. And then, if conditions are right, sand becomes sandstone, compressed by weight and time and mineral-rich water, and the whole cycle begins again. Small things become large things. Large things become small things. The transformation is continuous and patient and entirely without preference for which direction it moves. When you imagine a beach, imagine it as a library of former mountains, each grain a reduced piece of something that was once vast. Each handful a compressed history of erosion and time, and the continuous action of forces that never stop. The softness beneath your feet, if you have ever walked on a beach, was once the hardest kind of stone. Whales sing in frequencies that overlap with the earth itself. The lowest calls of blue whales, the largest animals that have ever lived on this planet, descend into infrasound, below the threshold of human hearing, into the same range occupied by the background hum of tectonic activity and the slow oscillations of the ocean floor. These calls travel thousands of kilometers through deep water. A blue whale singing in the North Atlantic can, under the right conditions, be heard by another whale near Iceland or the Azores. Researchers studying ocean acoustics have found that whale calls and seismic signals share frequency ranges in ways that are not coincidental. The ocean has its own acoustic ecology, shaped by the geology of the sea floor as much as by the creatures moving through the water above it. The whales evolved into a world that was already making sound. They found their frequencies in the spaces the Earth had left available. For tens of millions of years, before any human ear existed to hear either sound, whales have been calling through water, and tectonic tremors have been moving through rock, both at the same unhurried frequencies, both traveling enormous distances, both part of the same acoustic world that surrounds this planet continuously. The Earth and the largest creatures that swim in its oceans have been, in a very real acoustic sense, sharing a frequency for longer than our species has existed. They found the same note. They have been holding it together in the dark water and the deep rock, without knowing the other was there. In East Africa, a continent is slowly coming apart. The Great Rift Valley, which runs for thousands of kilometers from the Afar Triangle in Ethiopia down through Kenya and Tanzania and into Mozambique, is a place where the African continent is being pulled in two directions simultaneously, stretched by the movement of tectonic plates beneath it, and slowly, over millions of years, beginning to separate. The rift is already deep in places, already filled with some of the oldest and deepest lakes on Earth, Lake Tanganyika and Lake Malawi among them. These lakes exist because the ground has dropped between the pulling edges of the rift, creating basins that filled with water. They are, in a very real sense, the beginning of a future ocean. In approximately 10 million years, if the rifting continues at its current pace, the eastern portion of Africa will have separated enough that the Indian Ocean will flood into the rift, and a new sea will form, a new coastline, on land that is currently dry savanna and highland forest and ancient lakeshore. The animals living there now, and the people, and the cities, will be long gone, transformed by evolution and time into whatever comes next. But the water will arrive, patient as it always is, filling the space that the earth has been quietly preparing for it, slowly, for millions of years, one small tremor and 1 millimeter of separation at a time. On the morning of the 11th of September 2001, seismograph stations in the northeastern United States recorded something unusual. The instruments, designed to detect the movement of the ground from distant earthquakes, instead recorded a signal originating from Lower Manhattan, the collapse of the Twin Towers. Two events separated by approximately 28 minutes appeared in the seismic record as two distinct signals, measurable and identifiable, not because they were seismically large, but because the instruments were sensitive enough to detect anything that moved the ground significantly. The signals were later analyzed by seismologists at Columbia University's Lamont Doherty Earth Observatory. They could determine from the record the timing of each collapse, the duration, the approximate energy released. The ground had kept a record of what happened, as it always does, without judgment, without interpretation, simply registering the movement and preserving it in the data. The Earth records everything, not selectively, not with preference for what deserves to be remembered and what does not. Every movement, every weight, every vibration that reaches the crust is registered in the rock, briefly, as a seismic signal, and in the instruments, as a permanent record. The ground was witness to that morning in the most literal physical sense. It felt what happened, and it wrote it down, and the record exists still. At the center of the Earth, the pressure is so immense that iron, despite existing at temperatures higher than the surface of the Sun, remains solid. Under normal conditions, iron melts at around 1,500 degrees Celsius. The inner core of the Earth reaches temperatures estimated between 5,000 and 6,000 degrees Celsius. By any intuitive logic, it should be liquid. It should have melted long ago, but the pressure at that depth, generated by the weight of the entire planet pressing inward from every direction simultaneously, is so extreme that it prevents the iron atoms from moving freely enough to become liquid. The inner core is solid, not because it is cool. It is solid because it is squeezed. The pressure overrules the temperature. The weight of a planet holds its center together against the heat that would otherwise dissolve it. This is not a metaphor. It is physics. But it rhymes with something true about many things. That what holds a center together is not always the absence of heat, not always the absence of pressure, not always the absence of force. Sometimes a thing holds together precisely because of the forces acting on it from every direction. Sometimes being surrounded is what makes something solid. Sometimes what feels like pressure from the outside is what keeps the inside coherent, present, whole. You are held, tonight, by gravity, by the surface beneath you, by the air pressing gently on every surface of your body. You are, in a small and quiet way, being kept together by the world around you. There is a single earthquake, recorded in 1960, that geologists and seismologists still refer to simply as the Great Chilean Earthquake. It measured 9.5 on the moment magnitude scale. It ruptured approximately 1,000 kilometers of fault along the Chilean coast. The energy it released was greater than all other earthquakes in the 20th century combined. Tsunamis generated by the rupture crossed the Pacific and caused damage in Hawaii, Japan, and the Philippines, hours after the initial event. And yet, within a human lifetime, the coast of Chile rebuilt. The forests grew back. The communities returned. The fault that ruptured is locked again, accumulating stress, waiting. The landscape shows the evidence of what happened, if you know how to read it, but it does not announce itself. It has been absorbed into the geology, the way every event eventually is. The largest earthquake ever recorded happened 65 years ago. The planet absorbed it. The oceans absorbed it. The crust absorbed it. Life continued. The birds returned to the trees. The tide came in and went out as it always had. The ground rang like a bell for days. And then the ringing faded, and the silence returned, and the earth continued its long, patient work of being the earth, unchanged in any essential way by even the largest event it had experienced in a century. Two cores sit at the center of the earth, nested inside each other like a thought inside a thought. The outer core is liquid iron and nickel, thousands of kilometers thick, convecting in slow currents that generate the planet's magnetic field. The inner core, smaller, sits within the outer core, solid under pressure, rotating slightly differently than the rest of the planet above it. We have never seen either of them. No instrument has ever physically reached either. Everything known about them has been inferred from the behavior of seismic waves, from how they slow and bend and reflect and divide as they pass through the boundaries between each layer. The inner core was not known to exist until 1936, when a Danish seismologist named Inge Lehmann noticed a discrepancy in seismic wave data that could only be explained by the presence of a solid sphere inside the liquid outer core. She proposed the inner core from her desk, from her analysis of paper records of seismic waves, without any instrument going anywhere near it. The planet has two hearts, one liquid and churning and responsible for the magnetic field that shields life from the solar wind. One solid and ancient and rotating in its own slightly different rhythm, deep in the dark at a temperature that would vaporize anything a human being has ever touched. Both of them real, both of them there, right now, beneath everything, steady and present, and entirely unknown except by inference and mathematics, and the patient interpretation of waves that passed through them and came back changed. The free oscillations of the Earth, those long, low vibrations set in motion by the largest earthquakes and detectable by seismographs around the world, were first clearly measured after the 1960 Chilean earthquake. Before that, they had been theorized. Mathematicians had predicted, based on what was known about the Earth's interior, that the planet should have natural frequencies at which it would resonate if struck hard enough. like a bell that, if struck with sufficient force, would ring at predictable pitches determined by its size and shape and composition. The 1960 earthquake was hard enough. The instruments of that era, newly sensitive enough to detect the signal, recorded the Earth oscillating in dozens of overlapping modes simultaneously. The frequencies confirmed the theoretical predictions. The Earth was the size and shape and composition that the mathematics said it should be. The planet rang, and in ringing, confirmed what careful thought had suggested. It offered its own self-portrait, in the form of a vibration, to anyone with the instruments and the patience to receive it. Every large earthquake since has rung the Earth again, adding to the record, refining the picture. The planet is continuously offering this self-portrait in low frequencies, in passing waves, in the slow oscillations that seismographs detect and record, and scientists spend careers interpreting. It has never stopped. It is ringing, somewhere in its structure, right now, from earthquakes that happened yesterday and last week and last month. The echoes still present, still measurable, still telling their story to anyone listening carefully enough. In certain caves, deep enough that no surface sound reaches them, seismometers have been placed to listen. The rock around them is ancient and dense and utterly indifferent to weather or traffic or the movement of people above. In these caves, the instruments can hear things that surface stations cannot. The footsteps of animals moving through the cave itself. The drip of water from a stalactite, generating a faint percussion in the rock below. The slow settling of the cave walls as temperature changes over seasons, almost imperceptibly. And beneath all of that, the deep signal, the continuous background of the Earth's own movement, unmixed with human noise, arriving at the instrument as clean as it can arrive anywhere on the surface of the planet. Scientists have placed instruments in these caves specifically because the rock listens better than air. The cave is a kind of ear, shaped by water and time, offering a silence that is not empty, but full of what the Earth says when no one is making noise above it. There is a quality of attention available in very deep quiet. Not the absence of sound, but the presence of sounds too small to hear in a noisier environment. The Earth is always speaking. Most of the time the day is too loud to hear it. But in the caves, in the deep rock, in the patient darkness, the signal comes through, clear and low and continuous. The planet, saying what it always says, to instruments built by creatures curious enough to go underground to hear it. On the moons of Jupiter and Saturn, the ice cracks. Europa, a moon of Jupiter roughly the size of Earth's moon, has a surface of water ice covering a global ocean of liquid water beneath. The gravitational pull of Jupiter flexes the ice constantly, generating tidal stresses that crack the surface in long, curved lines visible from space. These cracking events are, in the most precise definition, moonquakes. Seismic events on another world, driven not by tectonic plates, but by the tidal force of a gas giant pulling at a frozen ocean. Enceladus, a moon of Saturn, goes further. It vents water vapor and ice particles from its south pole in great geysers that rise hundreds of kilometers into space before falling back or escaping into Saturn's ring system. The seismic activity that drives these eruptions comes from tidal heating, the same flexing and cracking of ice, but generating enough heat in the interior that liquid water exists beneath the surface. Liquid water, beneath the ice of a moon of Saturn, kept warm by the tidal pull of a distant planet. Scientists consider both Europa and Enceladus among the most promising places in the solar system to look for life. Not because they are comfortable or familiar, but because they have liquid water, and anywhere liquid water exists on Earth, life has found a way to be present. The seismic activity that cracks the ice may be the same activity that keeps the ocean beneath it habitable. The trembling of another world may be keeping something alive that we have not yet found. There are places on Earth where you can sit on bare rock and feel, faintly, the warmth rising through it. Not in volcanic regions only. In certain granitic outcrops, in exposed bedrock, in places where the crust is thin and the geothermal gradient is favorable, on a still day when the sun has not been heating the surface, the warmth you feel through your palms pressed flat against the stone is not solar. It is interior. It is the planet's own heat, conducted upward through kilometers of rock, arriving at the surface still warm enough to be felt by a hand quiet enough to notice. Geologists sometimes describe this as one of the small, unrepeatable pleasures of fieldwork. Sitting on ancient rock in a cool morning, hands flat on the surface, feeling something that has traveled from the deep interior of the planet to reach your skin. The heat at the surface is a tiny fraction of what exists below. Most of it never arrives. Most of it is absorbed and dispersed long before it reaches the crust. But some of it does arrive, slowly, through the rock. And if you are still enough, and the conditions are right, you can feel it. The earth is warm beneath you, always. Not in a way you can normally feel through floors and foundations and the insulating layers of a building. But the warmth is there, conducting upward, patient and continuous, from a source that has been generating heat since before the first ocean formed. You are resting above something that has been warm, without interruption, for 4.5 billion years. The crust of the earth floats, not dramatically, not visibly, but in the same physical sense that a piece of wood floats on water. The crust floats on the denser, more fluid mantle beneath it. The principle is called isostasy, and it governs the height of mountains and the depth of ocean basins, and the way the crust responds when weight is added to or removed from it. Where mountains are very high, the crust beneath them extends downward like a keel, floating deeper into the mantle to support the weight above. Where ice sheets melt and their weight is removed, the crust slowly rises, as observed in Scandinavia today. Where sediment accumulates in a river delta, the crust beneath gradually sinks under the added weight. The ground responds to what is placed upon it. It is not rigid in the way a floor is rigid. Given enough time, given enough weight, given enough change, it adjusts. It finds the level that the physics of buoyancy demands, slowly, over thousands of years, without complaint and without drama. You are resting on something that is itself resting. The crust floating on the mantle convecting above the core. Layer upon layer of things in dynamic balance, each one supporting what is above it, each one responding to what surrounds it. The whole system in a state of continuous, patient equilibrium that has held, in its essential character, for billions of years. Everything is resting on something, all the way down. Scientists are not entirely certain why earthquakes stop. The mechanics of how they start are reasonably well understood. Stress accumulates along a fault. Friction holds the fault locked until the stress exceeds the frictional resistance. The fault ruptures. A wave of energy propagates outward. This much is clear, supported by decades of observation and modeling and laboratory experiment. But why the rupture stops when it does is less certain. Some faults rupture for a few kilometers and then arrest. Others rupture for hundreds of kilometers and keep going. The conditions that cause a rupture to terminate, the exact combination of fault geometry and material properties and stress distribution that brings a propagating rupture to a halt, are still an active area of research, still debated, still not fully resolved. The silence after an earthquake is, In this sense, genuinely mysterious. Not the silence of a solved problem, but the silence of something that happened and then stopped for reasons that are understood only in outline. Science contains these honest edges, places where careful observation has brought understanding close but not all the way, where the question has been refined but not yet answered, where the most knowledgeable people in the world will tell you, without embarrassment, that they are still working on it. The earth keeps its own counsel on certain things. It moves when it moves, and it stops when it stops, and the pattern has not yet fully yielded to understanding. There is something companionable about that mystery, resting gently at the edge of what is known, waiting patiently for someone patient enough to find it. Rivers and fault lines share a secret. In many parts of the world, the path a river takes through a landscape follows, with quiet fidelity, the trace of a fault line below. The river did not choose this deliberately. Water finds weakness, and fault lines are weakness. Places where the rock has been fractured and ground and softened by repeated movement over millions of years. The river, following gravity and the path of least resistance, finds the fault and follows it, sometimes for hundreds of kilometers. The Colorado River follows fault structures through parts of the American Southwest. The Rhine follows rift structures through Germany. The Jordan River runs along the Dead Sea Transform, one of the most geologically active fault systems in the world. A river running along a fault is a collaboration between water and geology spanning millions of years. The fault made the weakness. The water found it. The river carved it deeper. The landscape that resulted is what you see when you stand on the rim of a canyon or the bank of a great river moving through ancient stone. The world is full of these collaborations, of things that found each other across vast time scales and, without intention or awareness, made something neither could have made alone. The river needed the fault. The fault, in some sense, was completed by the river. They have been working together, in their patient and unconscious way, longer than almost anything else currently visible on the surface of the Earth. A seismic wave, once generated, does not simply travel outward and disappear. It travels outward, and, when it reaches the far side of the planet and the surface above, it reflects. It bounces back. It crosses the planet again and again, diminishing with each crossing, losing energy to the friction of the rock it passes through, but persisting, in measurable form, for hours after the original event. A large earthquake, in this sense, keeps moving long after it has happened. The energy disperses and weakens and spreads, but it does not vanish instantly. It circles, it crosses and recrosses. It arrives at seismograph stations multiple times, from multiple directions, like an echo that comes from everywhere. Scientists use these reflections deliberately, studying the secondary and tertiary arrivals of seismic energy to refine their pictures of the Earth's interior. Each additional pass through the planet adds another layer of information, another angle on the structures the wave has traversed. The effects of a thing outlast the thing itself. The tremor ends and the wave continues. The moment of rupture is brief, and the record of it is long. What happens in an instant keeps traveling, in diminished form, long after the instant has passed. This is true of seismic waves, and it is true, in its own way, of many things. The stone dropped in the water, and the rings expanding outward, quieter with each moment, but present and real and still moving. Your blood carries iron. The iron in your hemoglobin, the molecule that carries oxygen through your body, is the same element that fills the Earth's core, the same atom, forged in the nuclear furnace of a dying star, billions of years before the solar system existed, distributed through the cloud of gas and dust that eventually became the sun and the planets, and, eventually, you. In the Earth's core, iron exists under conditions that make it behave in ways it never behaves at the surface. Solid under pressure despite extreme heat. Convecting in liquid form in the outer core, generating a magnetic field that extends tens of thousands of kilometers into space, shielding the surface of the planet from the solar wind that would otherwise strip the atmosphere away. In your body, iron exists in a very different form, bound into a protein, held in a specific configuration that allows it to grab an oxygen molecule and then release it, over and over, millions of times in a single day, delivering what your cells need to stay alive. The same atom, two completely different expressions of what that atom can do. One keeping a planet magnetically shielded, one keeping a body oxygenated. Both essential, both continuous, both happening right now, in this moment. One in the deep interior of the earth and one in the quiet of your own chest, working in the dark, doing what iron does, without pause and without acknowledgement, keeping things alive. The Earth's rotation slows, very slightly, after a very large earthquake. The mechanism is the same one a spinning ice skater uses when she pulls her arms inward to spin faster, or extends them to slow down. The distribution of mass relative to the axis of rotation determines the rotation rate. When a great earthquake occurs and enormous slabs of rock shift their position, the distribution of mass around the Earth's axis changes, very slightly, and the rotation rate adjusts in response. The 2004 Indian Ocean earthquake, which measured 9.1 and generated the devastating tsunami of that December, shortened Earth's day by approximately 2.68 microseconds. Not enough for any human to perceive, not enough for any clock to register with that extraordinarily precise measurement, but real. The planet's spin was altered by the rearrangement of its own mass. The Earth is a gyroscope and a clock simultaneously, and great earthquakes adjust both. The planet is sensitive, in this physical sense, to what happens within it. It responds to itself. Its outer events change its inner rhythms. Its surface movements alter its rotation. Nothing happens on the crust without the whole system, in some tiny measure, registering the change. You are part of this system. Your weight on the surface, distributed where you happen to be resting tonight, is part of the mass distribution of the planet, vanishingly small, utterly negligible in terms of any effect on rotation, but physically, genuinely, part of the same calculation. You are on the gyroscope. You are, in the most technical sense possible, part of what the Earth is carrying as it spins. A seismologist, reading a column of rock extracted from a borehole, can read the history of a continent. The layers speak clearly to a trained eye. This layer of ash came from a volcanic eruption dated to a specific time. This layer of glacial till indicates an ice advance. This change in the isotopic composition of the rock indicates a shift in ocean chemistry that corresponds to a mass extinction event. This layer of pollen indicates what grew here when this was a different climate. The rock column is a library, each layer a chapter. The chapters in sequence tell a story that no written history approaches in length or detail. The rock does not interpret. It simply records, in the chemistry and texture and composition of each layer, exactly what the conditions were when that layer was deposited. Everything that has ever happened on the surface of this part of the planet is written somewhere in the rock below it. Not everything is preserved. Not every record survives the heat and pressure of burial and uplift. But enough survives. Enough has been preserved, in enough places, that the broad outlines of the story can be read. The ground beneath you is a record of everything this place has been. Ice-covered, tropical, submerged, desert, each transformation faithfully recorded in the chemistry of the stone, waiting for someone patient and curious enough to bring a small cylinder of it up to the light and read what it has been holding, quietly and without urgency. For all this time, a freight train, moving along its tracks 3 kilometers away, can be detected by a seismograph. The rhythm is distinctive, regular, heavy, spaced. The intervals between the wheel impacts on the rail joints create a pattern that appears in seismic data as clearly as any signature, identifiable by anyone who has learned to read it. Seismologists call these kinds of signals cultural noise, meaning the seismic background generated by human activity, as opposed to the natural seismic signal they are trying to isolate and study. Cultural noise is everywhere in the seismic record. Traffic on highways, industrial machinery, wind turbines, construction, agricultural equipment, ships in harbors, trains on tracks, all of it arriving at seismograph stations as vibration in the ground, all of it requiring filtering and analysis to separate from the natural signals the instruments are designed to detect. In this sense, the human world is continuously legible in the rock. The rhythms of daily life, the patterns of work and travel and commerce, appear in seismic data as clearly as geological events, simply at different frequencies and with different signatures. The world you live in is always writing itself into the ground. The routines of daily life, the movement of people and machines and vehicles are being recorded continuously, in the most literal physical sense, by the rock beneath every road and every city and every quiet stretch of countryside. The ground is keeping a record of us, as it always has, as impartially and continuously as it keeps a record of everything else. Deep in the ocean, creatures navigate by the hum of the earth itself. Certain species of fish and marine invertebrates have sensory systems capable of detecting infrasound, the very low-frequency vibrations that travel through both water and rock, generated by tectonic activity, by the movement of ocean currents over seafloor ridges, by the distant rumble of underwater volcanoes. These sounds form a kind of acoustic map of the ocean floor, consistent enough and geographically specific enough that creatures sensitive to them can use them to orient themselves in water too deep for light to reach. The ocean floor has a voice, and some of what lives above it has learned to listen. This is not navigation by memory or by landmark. It is navigation by the sound of the planet itself, by the specific acoustic signature of a particular stretch of seafloor, by the frequency of the Earth's own breathing in a specific place. The creature does not think about it. It simply moves toward the frequency that means home. Somewhere in the deep ocean tonight, something small and ancient is finding its way in total darkness by listening to the sound the planet makes. It has been doing this, or something very much like it, for longer than our species has existed. The Earth has been a guide, a landmark, a home signal for creatures that never developed the capacity to think about what they were using. They simply used it, and it worked, and they are still here, navigating by the oldest map there is, the sound of the world, moving through the water saying, here, here, this way. Every grain of sand was once a mountain, and every mountain will one day be sand. The cycle has no preferred direction. It moves through both transformations continuously and simultaneously. While the Himalayas are rising, they are also being eroded. While the rivers carry sediment to the sea, that sediment is being compressed into new stone on the ocean floor. While ancient mountain roots are being exposed by erosion, new mountain roots are forming beneath growing ranges on the other side of the planet. The material is always moving, always being transformed. from solid rock to fragment to grain to sediment to stone and back again, over timescales that dwarf anything biology has produced. The atoms in a grain of sand on a beach in Vietnam may have been, in sequence, part of a coral reef, part of a coastal cliff, part of a river delta, part of a sandstone formation, part of a mountain range, and part of that beach. Each transformation taking millions of years, each one complete and real. Even as you rest right now, the mountains are being worn, grain by grain, invisibly, in the rain and the wind and the slow chemical dissolution of rock by water and weather. The process is so gradual it is imperceptible in a human lifetime, but it is happening tonight. On every exposed rock face, on every mountain, on every continent, quietly and without pause. The world is always becoming something else, always in the middle of a transformation, too slow to watch but too large to stop. And in that continuous becoming, nothing is ever truly lost. It is only rearranged, patiently, into whatever the conditions require next. The minerals in your blood were forged in dying stars, not metaphorically. The iron in your hemoglobin, the calcium in your bones, the magnesium that helps your muscles relax, the potassium that your nerves require to fire, none of these elements existed when the universe began. The universe began with hydrogen and helium and traces of lithium. Everything heavier was made later, inside stars, through the process of nuclear fusion that powers every star that has ever shone. When a sufficiently massive star reaches the end of its life and explodes as a supernova, it scatters these heavier elements outward into space. They drift as gas and dust. They aggregate, over millions of years, into new clouds. New solar systems form from these clouds. New planets condense. And on at least one of those planets, in at least one solar system, around at least one ordinary star, these elements eventually found their way into the chemistry of life. The iron passing through your blood right now was inside a star that died before the sun existed. It crossed interstellar space as dust. It became part of the cloud that formed our solar system. It became part of the Earth. It was incorporated into rock. It was weathered out of rock by rain. It entered the soil. It was taken up by plants. It was eaten. And eventually, through a long and extraordinary chain of events, it arrived inside you, doing the work of keeping you alive. You are made of star material doing biological work. The universe made you from its own remains. You are not separate from it. You are what it became, in this place, at this time, in this particular and temporary and extraordinary arrangement. The Earth's rotation slows by a small but measurable amount every century, and the reason is the moon. The moon's gravity raises tides not just in the ocean but in the solid rock of the Earth itself. A few centimeters of rise and fall twice each day, invisible but real. These solid Earth tides create friction as the rock flexes, and that friction gradually transfers energy from the Earth's rotation to the moon's orbit. The Earth slows. The moon, in response, moves very slightly further away. When the first complex animals were evolving in the Cambrian seas, approximately 540 million years ago, an Earth day was roughly 21 hours long. The year contained more days, because the Earth completed more rotations in the time it took to orbit the Sunday. Ancient corals, which lay down daily growth rings like trees lay down annual rings, preserve this record in their fossil skeletons. The rings can be counted. The count confirms the calculation. The days were shorter then. The nights were shorter. The moon was closer and larger in the sky. Everything that has ever lived on this planet has lived under a slightly different sky than everything that lived before it. The moon slowly retreating, the days slowly lengthening, the rotation of the planet gradually, imperceptibly, winding down. Tonight's darkness is slightly longer than any night that fell on the Cambrian Ocean. The moon is slightly further away than it was for the trilobites. The world you are resting in is not the world that any previous creature rested in. It is later. It is quieter. The rotation has slowed. The moon has drifted back, and the nights have grown almost immeasurably longer. There is an ocean trench in the western Pacific that descends nearly 11 kilometers below the surface of the sea. The Mariana Trench, at its deepest point, is deeper than any mountain on Earth is tall. If you placed Mount Everest at its bottom, the peak would still be more than 2 kilometers below the surface of the water above. The pressure at that depth is more than 1,000 times the pressure of the atmosphere at sea level. And yet things live there. Creatures that have adapted to the cold, the darkness, and the crushing pressure. Amphipods, small crustaceans, have been found in abundance at the deepest points. Microorganisms live in the sediment. The trench is not empty. Life found its way down and stayed. The trench exists because the Pacific Plate is subducting beneath the Mariana Plate, diving downward at an angle into the mantle, pulling the seafloor with it, and creating the depression that became the deepest place on Earth. It is, in geological terms, a relatively young feature. It will not always be there. Eventually, the subduction will continue until the sea floor that currently exists above the deepest part of the trench has been pulled downward and recycled into the mantle. The deepest place on Earth is temporary. The creatures living there do not know this. They have no need to know it. They are living in the deepest dark there is, in the cold and the pressure and the silence, and they are alive, and that is enough, and it has always been enough, for everything that has ever lived, in whatever conditions it found itself in. A fault that has been quiet for centuries is not a dead fault. Geologists make this distinction carefully and with some emphasis. A fault with no recorded historical earthquakes is not necessarily inactive. It may simply have a recurrence interval, the average time between major ruptures, that is longer than written history. A fault that ruptures every 500 years has been quiet for most of human civilization in most places. A fault that ruptures every 2,000 years may have no record of its previous event in any document that survives. The Wasatch Front in Utah, the fault system that runs beneath Salt Lake City, has a recurrence interval estimated at several hundred years for major earthquakes. The last large event on portions of the fault may have occurred before European settlement of the region. The fault is not dead. It is between events. Scientists call these sleeping faults, and they study them with a combination of trenching, where geologists dig across the fault trace and read the layers of disturbed sediment left by previous ruptures, and geodetics, where precise measurements track the slow accumulation of strain. The quiet is not the absence of something. The quiet is the accumulation of something, slowly, in the dark, in the rock, building toward a moment of release that may be centuries away or maybe sooner, on a schedule the fault itself determines, in response to forces that have been acting on it since long before anyone was measuring. Patience is not always rest. Sometimes patience is the accumulation of what a release will eventually require. The ground beneath Antarctica is one of the least understood surfaces on Earth. Beneath kilometers of ice, the bedrock of Antarctica is largely unmapped at the resolution that would be needed to understand its geology in detail. Radar surveys conducted from aircraft and from the surface of the ice have revealed the broad outlines. There are mountains beneath the ice, some of them substantial. There are deep basins, some of them below sea level. There are lakes, liquid lakes, kept from freezing by the pressure of the ice above and by geothermal heat rising from below. Lake Vostok, the largest of these subglacial lakes, is roughly the size of Lake Ontario. It has been isolated from the surface for somewhere between 15 and 25 million years. Whatever lives in it, if anything lives in it, has been evolving in isolation for that entire time, in cold and darkness and under enormous pressure, with no contact with the surface world above the ice. We do not know what is in Lake Vostok. We have barely begun to find out. A borehole drilled through the ice finally reached the lake's surface in 2012. But the science of studying what is there without contaminating it is extraordinarily difficult, and the work is slow and careful and ongoing. There are places on this planet that remain genuinely unknown. Not metaphorically unknown, not poetically uncertain, but actually, literally unknown, where what exists has not yet been seen by any human eye or instrument with sufficient resolution to describe it. The world is still larger than our knowledge of it. It has not yet been fully read. There are still chapters beneath the ice, waiting in the cold and the dark, patient as everything in geology is patient, for the right question and the right instrument and the right moment of careful attention. When two tectonic plates lock together along a subduction zone, they are making a promise they will eventually keep. The locked section of fault accumulates strain. The overriding plate bows slightly downward, compressed against the descending plate, deforming in ways that GPS instruments can measure precisely. The coastline above the locked zone subsides slowly. The ground tilts, almost imperceptibly, year by year, as the strain builds. And then, when the lock releases, the motion reverses rapidly. The overriding plate springs back, the coastline rises, the seafloor lurches upward, and if the displacement is large enough and occurs in shallow water, the sudden movement of the seafloor displaces the ocean above it, and the displaced water moves outward in all directions as a tsunami. The tsunami is not a wave in the usual sense. It is the ocean responding to a sudden change in the shape of the floor that holds it. It is the water doing what water always does, filling the available space, moving from where there is more to where there is less, following the physics of fluids with absolute fidelity. The ocean does not intend the wave. The fault does not intend the tsunami. The physics simply proceed as they always do, consequence following cause, with the patient indifference of natural law. The promise of movement, accumulated over centuries in locked rock, kept in a moment. The debt of strain, repaid in full, in the way the earth always repays what it owes, completely and on its own schedule. There is a warmth in the soles of your feet if you were to press them against the earth directly. That comes from further away than you can easily imagine. Not the warmth of the day's sun, stored in surface soil. Not the warmth of a heated room conducted through a floor. The warmth that rises from depth, from the geothermal gradient that increases as you descend through the crust, from the radioactive decay of elements in the rock below, from the original heat of planetary formation that has been conducting upward through kilometers of stone for 4.5 billion years. In some places, this warmth is strong enough to feel clearly. In volcanic regions and geothermal zones, where the gradient is steep and the crust is thin. In most places, it is subtle, masked by surface temperature changes and insulated by the materials of human construction. But it is always there, rising, slowly, through the rock, through the foundations, through the floor, through the small remaining distance between the Earth's interior and wherever you are resting tonight. The planet is warm beneath you, has been warm beneath every creature that has ever rested on its surface, has been warm continuously, without interruption, since before the first ocean formed, since before the first raindrop fell, since the time when this world was still assembling itself from the debris of the early solar system. The warmth is old, it is patient, it does not hurry upward, it simply rises, as heat always rises, toward the surface where you are, quietly, continuously arriving. The ground does not think of itself as solid. At the scale of atoms, the rock beneath you is almost entirely empty space. The atoms that make up granite or limestone or basalt are themselves mostly void, their electrons occupying probability clouds around nuclei so small that if an atom were the size of a football stadium, the nucleus would be a marble at the center. The apparent solidity of stone is a property of the electromagnetic forces between atoms, the way they resist being pushed together, not a property of the matter itself. At the scale of the mantle, rock is not solid in any intuitive sense. Given enough time, and enough heat, and enough pressure, it flows. The same material that feels immovably hard when you press your hand against a stone wall will, over millions of years and under the right conditions, move like a very slow, very thick fluid, carrying continents on its back, convecting in vast loops driven by the heat of the interior. Solidity is a relationship between a timescale and a material. At human timescales, rock is solid. At geological timescales, rock flows. The stone beneath you is both things simultaneously, depending only on how long you are willing to wait. You are resting on something that is solid tonight and fluid across the span of deep time, something that holds you firmly in this moment and has been slowly moving for billions of years. The ground is patient in a way that changes its nature entirely depending on the length of your attention. Perhaps the most stable things are like that. Firm when you need firmness, yielding, over time, to whatever the forces require. Scientists can see ancient earthquakes in the landscape without any instrument at all. A stream that suddenly offsets its course, bending sharply as it crosses a fault trace, tells a geologist that the ground moved laterally at some point in the past, carrying one bank of the stream away from the other. A terrace of raised beach gravel sitting meters above the current shoreline records a moment when the coast was suddenly lifted by a great earthquake. A hillside of tilted, contorted rock layers preserves the memory of compression and folding from an ancient collision of plates. The landscape is a record, not a static picture, but an accumulating archive of every significant event that has shaped a region since the rock was laid down. Geologists trained to read it can walk across a hillside and describe events that happened millions of years ago with the same confidence a librarian describes books they have read. This reading requires patience and the willingness to let the landscape tell its story at its own pace. A geologist does not arrive at an outcrop with a conclusion. They arrive with a question, and then they look, carefully, and for a long time, and they let the rock answer in the language of its own structure. The world is full of records, written in forms that require particular kinds of attention to read. The rock reads one way, the water reads another, the sky reads another still. None of them use words. All of them are saying something, continuously, to anyone willing to learn how to listen in the right way for what they are offering. The atom of oxygen you just breathed in may have spent time inside a volcano. Not recently. Not in any way that connects to anything currently erupting. But oxygen cycles through the Earth's systems over geological time in ways that make its history extraordinary. Volcanic eruptions release gases, including water vapor and carbon dioxide and sulfur compounds, that enter the atmosphere and the ocean. The ocean absorbs carbon dioxide and incorporates it into the shells of marine organisms. Those organisms die and sink and are compressed into limestone. The limestone is subducted into the mantle, The mantle melts it. A volcano erupts it back into the atmosphere. The same atoms cycle through this system repeatedly, over hundreds of millions of years. An oxygen atom currently in the atmosphere may have made this circuit multiple times, may have been inside a shell, inside limestone, inside the mantle, inside a volcanic plume, inside the atmosphere, inside a raindrop, inside an ocean, inside a shell again. The air you are breathing right now has a history longer and stranger than any story. The specific atoms moving through your lungs at this moment have been in places and conditions utterly unlike anything your body represents. They have been inside stone. They have been inside the mantles of the earth. They have been briefly, improbably, inside the bodies of creatures that lived and died before the continents were in their current positions. And now they are here, inside you, briefly, on their way somewhere else. You are one stop on a journey that was already ancient before you began. Tectonic plates do not move alone. They are coupled to each other at their boundaries, locked along subduction zones and transform faults, pulling against each other along spreading ridges, transmitting stress across distances of hundreds of kilometers through the rigid rock of the plates themselves. A change in the motion of one plate affects the stress on every plate it touches, and those plates touch others, and the adjustments propagate through the entire system. The plate tectonic system is a single, global, interconnected mechanism. Every plate is part of the same machine. No plate moves entirely independently. The motion of the Pacific plate affects the stress on the North American plate, which affects the Caribbean plate, which affects the South American plate. The connections are not always direct or simple, but they are real, and they have consequences. This interconnection means that a large earthquake in one part of the world can, by altering the stress distribution on a fault system thousands of kilometers away, either bring a distant fault slightly closer to failure or move it slightly further away. The effect is small. The distances are vast, but the connection is there, written into the physics of how rigid plates transmit stress across their surfaces. Nothing in the tectonic system is isolated. Everything is touching something that is touching something else. The whole surface of the Earth is connected through the rock in a continuous mechanical network that has been transmitting the forces of the planet's interior to its surface since the plates first formed. You are on this network tonight, resting on one small piece of a connected whole that has no edges, no gaps, no place where the transmission stops. When you lie still, the room around you is vibrating, not from anything mechanical, not from traffic or wind or the building settling, though those add to it, from the ocean, from waves breaking on coastlines, perhaps thousands of kilometers from where you are resting, generating the microseismic signal that seismologists call the secondary microseismic peak, a continuous vibration in the frequency range of roughly 0.1 to 0.3 Hertz that travels through the crust of the entire planet. Every seismograph ever operated, in every country, on every continent, shows this signal. It is the most consistent feature of the global seismic background. It does not stop at night. It does not diminish in winter. It is as constant as the ocean itself, because it is generated by the ocean itself, by the interaction of ocean waves with each other and with the sea floor, propagating outward through the rock in all directions. The room you are in is moving at frequencies far too low to feel. Frequencies so low that a single cycle takes several seconds. The kind of motion that registers as presence rather than sensation, if it registers at all. The ocean is in the room with you, in the most literal physical sense. Its rhythm is present in the floor beneath you, in the walls around you, in the ground outside. continuous and ancient and indifferent to distance. The ocean found you here, as it finds every place, through the rock, through the deep and patient medium of the crust, arriving as it always arrives, quietly, without announcement, already there before you noticed. There are earthquakes happening on Mars. The InSight lander, which touched down on the Martian surface in 2018 and operated until late 2022, carried a seismometer of extraordinary sensitivity and detected hundreds of Marsquakes during its mission. Most were small. The largest reached approximately magnitude 5, modest by Earth standards, but significant for a planet that does not have tectonic plates in the way Earth does. Mars is not tectonically active in the same sense. It does not have the continuous cycle of plate creation and subduction that drives Earth's seismic activity. Its quakes arise instead from the slow cooling and contraction of the planet's interior, from the thermal stresses that build as the planet loses heat over billions of years, and possibly from the gravitational pull of its moons, Phobos and Deimos. The seismometer detected these events through months of Martian night, sitting on a cold and dusty plain, listening for the faint movements of another world's interior, and it heard them. Regular, small, distant rumbles from somewhere deep in the Martian crust. The planet still adjusting, still contracting, still releasing the stress of its own slow cooling. We have felt another planet's heartbeat. Not from a distance, not through inference, but with an instrument sitting on its surface, recording its trembling in real time. Mars is not silent. It is simply quieter than Earth, and its trembling comes from a different source. But it is there, and it was there long before we arrived to listen, and it will be there long after InSight has been buried by Martian dust. The horizon you can see from wherever you are is curved. You cannot see the curvature from ground level. The Earth is too large, and the distance is too short for the curve to be apparent to an eye standing on the surface. But it is there. The horizon is not a straight line. It is the tangent point of a sphere, the place where your line of sight just grazes the surface and can go no further. And beyond it, the surface curves away, downward, out of sight. Everything beyond your horizon is still there. The cities, the oceans, the mountain ranges, the sleeping people, the open fault lines accumulating their patient tension, the mid-ocean ridges generating new sea floor in the dark, all of it present, all of it real, all of it continuous with the ground you are resting on, simply curved away beyond the reach of your particular position and the particular range of your sight. The Earth is not small enough for you to see its edges. You cannot stand anywhere on its surface and see the whole of it. You are always inside it, in a sense, surrounded by more of it in every direction than you can take in at once. This is not a limitation. It is a kind of shelter. You are held inside something large enough that it has no visible boundary from where you stand. Something that extends beyond your sight in every direction, solid and continuous and patient, carrying you at its surface, curved around you like a palm around something small and warm, and worth the care of holding. The deepest hole ever drilled by human beings reached approximately 12 kilometers below the surface. The Kola Superdeep borehole in Russia, begun in 1970 and drilled for more than 20 years, reached that depth and then stopped. Not because the machinery failed, but because the rock at that depth was so hot, nearly 180 degrees Celsius, that it behaved plastically, closing around the drill bit faster than it could be removed. The hole defeated its makers, not with hardness, but with a kind of slow, warm yielding that made further progress impossible. 12 kilometers. Into a planet whose radius is more than 6,000 kilometers. The deepest physical penetration humanity has ever achieved into the Earth reaches less than 0.2% of the distance to the center. Everything known about the deep interior has been inferred. Seismic waves, gravity measurements, magnetic field analysis, laboratory experiments simulating high pressure and temperature conditions. The picture assembled from these methods is detailed and consistent and scientifically robust, but it is entirely indirect. No instrument has ever physically been there. No sample has ever been brought up from more than a few kilometers down. The interior of the planet you are resting on tonight is, in the most precise sense, unexplored. It is the largest unexplored territory remaining on Earth, and it is directly beneath you, separated from the surface where you lie, by a distance that all of human technology has barely begun to cross. You are resting at the edge of the most unknown place on the planet, looking outward at the stars, while the greatest mystery is in the direction you are pressing your weight against tonight. Your sense of stillness right now is one of the most elaborate illusions in nature. You are on a planet rotating at more than 1,000 kilometers per hour, orbiting a star at 30 kilometers per second, moving with that star around the galactic center at approximately 220 kilometers per second, moving with the galaxy through the local group, moving with the local group through the larger structure of the universe, toward the Great Attractor, a region of concentrated mass hundreds of millions of light-years away, at speeds that make all the previous numbers seem modest. None of this is felt. None of it registers in the body as motion. The vestibular system in your inner ear detects acceleration and change in motion, not constant velocity. And since all of this motion is constant, or changes so gradually over human timescales as to be imperceptible, none of it reaches consciousness as movement. You feel still. You are, in the deepest physical sense, anything but still. You are being carried at extraordinary speeds through space, on a planet that is turning, that is orbiting, that is drifting with its entire stellar neighborhood toward a gravitational concentration too large and too distant to see. And yet the feeling of stillness is real. It is a real feature of your real experience. The body is not wrong to feel it. It is simply describing its own frame of reference accurately. Within that frame, you are still. And within the frame of the universe, you are in motion beyond anything the body was built to register. Both are true. You are still. You are moving. The universe is generous enough to offer both at once. And tonight, resting here, you are quietly experiencing both, without having to choose. Hello there, and welcome to the Drift to the Stars. I'm so glad you found your way here tonight. Wherever you are right now, tucked into bed, stretched across a sofa, lying quietly in the dark, you made it here. That's enough. You don't need to do anything else tonight. There's nowhere to be, nothing to solve, no version of yourself you need to perform. This is simply a place to rest, and to drift, and to let the world grow gently large around you, while your body grows gently heavy. And just before we begin, if these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, if you're ready, let's begin. There is a sound the earth makes that no human ear has ever heard. Not because it is too loud, not because it is hidden, but because it is too slow, too deep, too constant, like trying to hear the color of a room you've lived in all your life. It moves through everything, through the oceans, through the bedrock, through the floor beneath you right now. Scientists call it the Earth's hum, a continuous, low vibration that rises from the planet's own interior, its own movement, its own living weight. Even in the most soundproofed room ever built, this hum is present. Even in the quietest valleys on the quietest nights, it is there. It does not announce itself. It simply continues, the way a river continues whether or not you're watching it. Think of it as a song with no beginning and no planned ending. A note held for 4.5 billion years. You have been inside this song for every moment of your life, without knowing it. And there is something quietly comforting in that. The earth has been making this sound since long before there were ears to miss it, and it is making it still, right now, as you settle into stillness. You are not in silence. You are in the oldest music there is. Now hold that feeling of vast, slow sound, and then consider something much smaller. Consider a single thunderstorm, the kind you might watch from a window flicker of light, a low roll of sound, rain moving across a field in grey curtains. From where you sit, it seems enormous. The sky itself seems to be rearranging. But from space, from a satellite watching in infrared, a thunderstorm is a small and temporary brightness, a smear of light on a blue-grey surface. And here is what gently undoes expectation. Even a great earthquake, the kind that reshapes coastlines, that geologists name and remember, releases less total energy than that single thunderstorm, viewed from that same distance. It is not that earthquakes are small, it is that weather is enormous, and we forget. The atmosphere above you is constantly churning, releasing energy in quantities that dwarf the grinding of continents. The sky is wilder than the stone. A magnitude 8 earthquake releases roughly the energy equivalent of about 6 million tons of TNT. A large thunderstorm system can release several times that over its lifetime, in heat, wind, and electrical discharge. The ground beneath you is patient. The sky above you is the restless one. And right now, both are holding you, from below and above, like a hand cupped around something small and warm and worth keeping. Somewhere inside you, there is stone. Not metaphorically, not as poetry. Literally the calcium in every bone you have ever grown, the magnesium that moves through your blood, the silicate traces in your hair and skin, these are minerals. The same category of matter that makes up the tectonic plates sliding beneath every continent on Earth right now. You are, in a measurable chemical sense, made of the same stuff as fault lines. Imagine the bones of your hand, the fine architecture of them, the way they hinge, the way they hold. Now imagine those same minerals under different conditions, compressed by unimaginable weight, heated by the interior of a planet, folded over millions of years into ranges of stone. That is what the Earth did with the same atoms. And then, somehow, across an incomprehensible chain of events, some of those atoms found their way into you, into the quiet machinery of your living body. The pressure that builds along a fault line and the pressure that built your skeleton are not the same, but they rhyme. The Earth made both from the materials it had. It did not distinguish. It shaped rock, and it shaped you with the same patient chemistry. You are not a visitor to a geological world. You are a geological event, a temporary, breathing, wandering arrangement of the very same matter. Right now, as you read this, or as this voice reaches you in the dark, the ground is moving somewhere on Earth. Not in a way anyone will feel, not in a way that will make the news, or rattle a window, or wake a dog. Somewhere, a small seam in the rock gives way. Somewhere, a fault that has been holding steady for years releases a fraction of its tension. The movement is tinier than a grain of rice shifted across a table, but it is real, it is measurable, and no creature in the world notices. Seismologists estimate that the Earth experiences roughly 500,000 detectable earthquakes every year. That is nearly 1,400 per day, nearly one per minute somewhere on the planet. Most of them happen beneath ocean floors. Most of them register so low on the scale that the most sensitive instruments can only barely catch them. They are like the smallest exhales of a sleeping person, real breaths, just quiet ones. And somehow, knowing that is not alarming. It is settling. The Earth is always releasing, always adjusting, always making these tiny, unheard corrections. It has been doing this for billions of years, and the mountains are still here. The oceans are still in their places. You are still here. All that adjusting, and still this much stability. The planet is not fragile. It is alive. The deepest earthquakes on Earth happen in a place no human instrument has ever physically visited, and no human being will ever go. Nearly 700 kilometers below the surface, far deeper than any drill has ever reached, far deeper than the deepest mine, far deeper than the deepest ocean trench. There is a region where the rock is no longer rock in the way we usually mean it. The pressure is so severe that minerals transform into new forms, denser and stranger, that do not exist at the surface. The temperature is hot enough to melt most things, but the pressure keeps the rock from melting entirely. It flows, instead, slowly, like something between a solid and a dream, and through this zone, earthquakes still happen. A stress still builds. A release still occurs. A seismic wave still rises upward through 700 kilometers of layered earth, and eventually, almost gently, reaches the surface as a barely measurable whisper. It is extraordinary that we detect them at all, that a movement in a world utterly invisible to us, under all the cities, under all the oceans, under all the history, can still reach up and announce itself, still make itself known. There is something quietly wonderful in that. Depth does not mean silence. Even what is most hidden still sends something upward. Even what is most remote still arrives, eventually, at the surface where you rest. A seismic wave, the energy released by an earthquake, travels through the earth at several kilometers per second, through dense rock, through liquid iron, through the strange interior regions of the planet. It moves and curves and reflects until it has visited the entire sphere. And here is where scale does something gentle to the mind. Light, traveling from the surface of the sun to the surface of the earth, takes about 8 minutes. A seismic wave, traveling through the entire planet, not across it, but through it, pole to pole, takes roughly 20 minutes. Light and earthquakes. One crosses 150 million kilometers of empty space. The other crosses 12,700 kilometers of dense, layered rock, and they arrive at their destinations within minutes of each other. It is not a competition. It is a proportion, a way of holding two enormous things beside each other until the mind stops trying to measure and simply rests in the comparison. The planet is not small. The speed of light is not modest. And somehow they rhyme. When sunlight is falling on your window, soft morning light, or the last orange of an afternoon, a seismic wave somewhere is moving through rock at a pace that is, in its own way, just as astonishing. Both are traveling. Both are real. Both pass through and around and over the place where you quietly exist. Long before seismometers, long before anyone understood fault lines or tectonic plates, ancient people built sacred structures on living ground, and they did not always know why. Temples in Greece, sanctuaries along the Anatolian coast, certain cathedrals in Italy, oracle sites, healing centers. Many of these, when mapped by modern geologists, sit directly on or very near to active fault lines. The connection is not coincidence, researchers believe, but an ancient, unnamed sensitivity. The ground, near a fault, often produces strange phenomena. Faint smells of rising gases, occasional ground-level sounds too low to identify, the faintest vibration underfoot on certain days. People felt something. They could not name it. They built temples. Whether the experience was sacred or geological, or both, in some way we have lost the language, for there is something tender in that history. Humanity has always been drawn to the places where the earth is most alive, even without instruments, even without understanding. Something in the body recognized the living quality of the ground. You don't need to be near a fault line tonight to feel that recognition. You are resting on a planet that is breathing beneath you, and some part of you very quietly already knows. The ocean floor is the most active surface on Earth, and also the most quiet. More than 70% of all volcanic activity on the planet happens beneath the ocean, along the mid-ocean ridges, where tectonic plates are slowly pulling apart. New seafloor is being created right now, in the dark, miles below the surface, in water so cold and pressurized that the magma cools almost instantly into strange, rounded shapes called pillow basalts. And as this happens, tiny tremors ripple outward micro-earthquakes, so small they are measured in fractions of a degree. The ocean absorbs these entirely. No wave reaches shore. No instrument onshore detects anything. The movement happens in total, absolute silence, muffled by miles of cold water and the weight of the world above it. Imagine moving so gently, so far beneath attention, that even the restless ocean doesn't transmit your presence. That is the daily reality of the seafloor. It changes constantly, in the dark, under immense pressure, in cold and silence, without any witness. And yet it is real. And yet it matters enormously, shaping the ocean basins, regulating chemistry, building the foundation of every coast you have ever seen. Work does not require an audience. Quiet change is still change. The world is made, in large part, by things no one has ever seen. Here is something that reorders the world a little. Modern seismometers, the instruments that detect earthquakes, are sensitive enough to detect a sparrow landing on a branch nearby. Not metaphorically, not approximately. A small bird, alighting on a wooden branch 50 meters from a buried seismometer, produces a vibration in the ground that the instrument can detect and record. The footsteps of a single person walking across grass can be measured at a distance of 10 meters. The passage of a car on a nearby road appears as a clear, identifiable pattern on a seismograph. A thunderclap, a wave breaking on a distant shore, a large crowd beginning to applaud. The ground carries everything. It does not filter for importance. It does not decide which vibrations deserve recording. It simply transmits faithfully, without judgment, every pressure, every weight, every movement placed upon it. And your body, right now, is part of that record. Your heartbeat creates a tiny mechanical wave in your chest that travels into the surface beneath you. If you are lying down, the ground beneath you is, in the most literal physical sense, registering that you are here, that you are alive, that your heart is beating. The earth knows you are resting on it, not in a poetic sense, in a physical one. You have always been felt. The mantle, the vast layer of rock between the earth's crust and its core moves. Not quickly, not in any way you could watch, but it moves. The rock there, under enormous heat and pressure, behaves over millions of years like an extraordinarily viscous fluid. It convects hot material rising, cooler material sinking, in vast, slow loops that carry continents on their backs. The speed of this movement is roughly the same as the speed at which your fingernails grow. 1 to 2 centimeters per year, a few millimeters per month, less than a hair's width per day. And yet it has moved India across the Tethys Ocean and into Asia, raising the Himalayas in the process. It has opened the Atlantic. It has carried Australia northward from Antarctica. All of it at the speed of a growing fingernail, without hurry, without urgency, over time scales that make human history feel like a single breath. There is such peace in that pace. Nothing about the Earth's interior is rushed. It does not try to go faster. It moves at exactly the rate that its nature allows, and in doing so, it remakes the surface of the entire planet. You don't have to be fast to matter. You don't have to be sudden to be powerful. The slowest forces on Earth are the ones that make the mountains.